So what we're going to look at right now is how to optimize area and perimeter. And what does optimization mean? Well, it means to determine the best possible solution for some given certain constraints. Okay? So if we have a fixed area and we need to optimize the perimeter, that means we need the best possible solution. So typically what we want to do is we want to minimize the perimeter of something. Remember, the perimeter is the distance around something, or we want to maximize the area of it. And the reason for that is minimizing perimeter. Okay, if we have a large perimeter, then we're going to need more materials. Okay, so it's usually important to minimize perimeter because of the cost of materials. And basically, if we can minimize the perimeter, then we can minimize the amount of materials, and therefore we can minimize the cost of them. If we want to maximize the area, what that means is we want more space. So having these two things together, minimizing perimeter while maximizing area, is optimally our best solution. So in order to minimize the perimeter, okay, we want to figure out what is the best possible way to do this. Usually there are some given constraints. So in this situation, example 1, J has 36 square patio tiles that have side measurements of 1 feet. So that means we have a whole bunch of tiles that are basically 1 foot by 1 foot. Okay? And J wants to put a railing around the patio to enclose it. To minimize the cost, he wants the perimeter to be as small as possible. Okay? So basically he already has the tiles, okay, 36 square patio tiles, so he's going to have an area of 36 square feet no matter what he does with the patio tiles. But in order to put something like a fence around it, okay, he's going to want the perimeter to be as small as possible. What are the dimensions of the deck that will minimize his cost? Okay, so let's just take a look at this situation here. We have a whole bunch of different options that he can do. Okay, we want an area of 36 square feet no matter what. Okay, but we can change the length and the width to give us that area. So the first thing I can think of is one way to get 36 is to do a 36 by 1, okay, a 36 by 1 patio. Basically that just means take each patio square and line them up straight in a row. So the length of this would be 36 feet. The width would be 1 foot. And so our perimeter would be 2 multiplied by the 36 plus 1. There's 2 of each of these lengths. So that's going to give us 74 feet. And then area would be 36 times 1, 36 square feet. Okay. So we have our 36 square feet, and this shape would give us a perimeter of 74 feet. If we want to do a different shape, will that give us the same perimeter? Okay. Let's try it out. We know we need an area of 36. So if we take 36 and divide it by 2, so if I put 2 tiles side by side here and build up, I'm going to have a length of 18. So a length of 18 feet, width of 2 feet, my perimeter is now going to be 2, and then we're going to have 18 plus 2. So my perimeter is now 40 feet. So my perimeter has gone down. By making it 2 widths, okay, 2 tile widths instead of 1, my perimeter has gone down to 40 feet. But you can see the area has not changed, 36 square feet. So we're remaining a constant area, and we're also, okay, decreasing the perimeter so far. Okay. One thing that's important to note is the reason I've done 1 tile here and 2 tiles here, we're not going to cut all of the tiles up. Okay, that's one of the constraints, is that we can't have a length of 1.5. It's got to be a whole number because we have these tiles we're working with. So this is 1, 2. We can divide, 36 can be divided by 3. Okay, and if we divide it by 3, now we've got a length of 12 feet. So let's see what happens to our perimeter. We've got 2 multiplied by 12 plus 3. Okay. Now our perimeter is 30 feet. Okay. And our area is still, because I took the 36 and divided it, 36 square feet. 36 can also be divided by 4. So if I have a length of 4, Okay, now I've got 9. A 4 by 9 also gives us an area of 36 feet. Square feet. Okay, perimeter for this one would be 2 times 9 plus 4. So our perimeter for this shape would be 26 square feet. Whoops, feet. Perimeter's in feet. Okay, 26 feet. So it keeps going down. The more we make it wider, okay, the closer we bring these two values together, the more we are able to minimize our perimeter. And if we can't divide 36 by 5, but we can divide it by 6 and 6. So 6 by 6. Oh, that's 24 feet. Now we're getting, the jump between these two is only 2 feet, but it's still smaller. Okay. If we go one further, okay, and we try to make this bigger again, okay, the next number that'll go into 36, it's bigger, is 9. So now we're just going back to this shape and reversing the numbers. So there's no point. This is kind of our natural stopping point. So these are all of the possible ways that you can design this patio. They all have the same area, so what we're trying to do is optimize the perimeter, which means makes the perimeter as small as possible. So this is our absolute best answer for this one. The best way to get our perimeter as small as possible, okay, is a 6 foot by 6 foot, which is a square. Square patio would have the smallest perimeter, with an area of 36 square feet. Okay, so that's the smallest area possible. Now, in general, okay, if we have any shape and we're trying to minimize it, okay, if we have any rectangle and we're trying to minimize the perimeter, okay, the closer the rectangle is to being square, the smaller the perimeter will be. Okay, so this can happen if both the length and the width are equal. Okay, if it's not possible to create a square, so in other words, our number was an area of 36, so it's possible to create a 6 by 6 square for that one. If it's not, the rectangle it is as close to a square as possible is the best one. Okay, so you always want to get your rectangle as close to being a square as possible. So let's take a look at another example. So in this one, minimize perimeter using knowledge of the square. Determine the dimension of a rectangle with an area of 195 meters square that will minimize the perimeter. Okay. So we know we need, okay, an area of 195 meters squared. Okay. So we need to be as close to a square as possible. Okay, so there's a couple different ways to do this. If we absolutely need to keep it as whole numbers, so we can't have decimal numbers, then that's a very different question than with decimals. So let's take a look at both situations so that no matter what situation you're in, you know how to answer the question. So if we're going to use whole numbers, okay, whole numbers. Okay, so we're going to need to figure out some factors of 195, and we're going to want those numbers to be as close together as possible. So 195, we could have I think the first smallest number, 2 won't go into it, so we could have a 1 by 95 by 195, which is probably the worst, the worst possible one you could do. We could have a 3 by 65. We could have a 5 by 39, and then I think the next one would be a 13 by 15. And then if we go up more, once again, then we're going back to one that we've already done. So the 13 by 15 is these two numbers are the closest together. These two are still pretty far apart. 13 and 15 are only 2 numbers away. So therefore, a 13 meter by 15 meter is the smallest perimeter. Okay. If you're using something like, you're just minimizing area for, say, you're going to cut some wood to design your perimeter, then you don't necessarily need to use whole numbers. So if we're allowed, we'll just say it with decimals. If you're allowed to use any number, okay, then we can just take the square root of 195. And if I take the square root of 195, that's going to give me 2 numbers exactly the same, that when I multiply them together I get 195, which is exactly how you find area. So if we take 195, it's approximately 13.97. So if we had a 13.97 meters by 13.97 meters, this would optimize perimeter. Or in other words, make the perimeter as small as possible. Okay. I think I'm going to do maximizing area in the next video so that you can just stop here if you want for minimizing perimeter. And if you have any questions, let me know.